Jai Hind everyone. I am Anupam Kumar Saini, Assistant Professor, IT Department, AKGEC Ghaziabad. Today I am going to discuss important topic of discrete structure and theory of logic. This is the subject of computer science, IT and allied branches of computer science. So one of the important topic is the rules of inference. So proof in mathematics are valid argument. An argument is a sequence of statements that end in a conclusion. Means there will be some statement that have premises and conclusion. By valid, we means the conclusion must follow from the truth of the preceding statements or premises. We use rules of inference to construct valid argument. To find out the arguments are valid or not, there are two methods. One method is with the help of truth table and other one is with the help of rules of inference. So valid argument in propositional logic is known with the help of following. Is, for example, is this a valid argument? This is written here: if you listen, you will hear what I am saying. So with the help of proposition, first we have to convert it in propositional logic. So first statement is if you listen, then we represent you listen represent with the proposition P and you hear what I am saying with Q. So there are two premises and one conclusion. As said here, the valid argument means the conclusion must follow with the truth table preceding statement or premises and conclusion are two things in to find out the validity, a valid argument. So these are premises and this is conclusion. So first we convert it in propositional logic form. So the argument has the form you listen means P, you will hear what I am saying. We write it here is with the help of Q, it represents Q and it represents P as written. So P implies Q. If you listen, you will hear what I am saying. So this statement is written. If you listen, then you will hear what I am saying. Next premise is you are listening. So P. And this is the conclusion. You hear what I am saying. So this argument is in this form. We can write it P implies Q, P, then Q. So these are the premises and this is conclusion. To check valid argument in propositional logic, we can write it in this form. Premises apply AND operation and conclusion implies then conclusion. So we write it here. First premises P implies Q, and P implies means conclusion Q is a tautology. If is a tautology means if premises and conclusion are true, in that case the argument will be valid. If these premises and the conclusion, all these are true, then the argument will be valid. We can write it here in the form of truth table. So P and Q, two variables are there. So we write it P, Q, P 0 0 1 1, Q 0 1 0 1, and P implies Q. So we take two variable P and Q. P 0 0 1 1 and Q 0 1 0 1. So P implies Q will be true when P will false, else both P and Q will true. When P is false, then the P implies Q will true, else both P and Q are true, then P implies Q will true. So these at these condition, it's 1 means 0 0, P is 0 and Q is 0 means P is false, then Q is also false, then P implies Q is true. It depends only on the first element. The first element is false, then the result will be true. Else both the P and Q is true, then P implies Q will be true. So P implies Q and P. So P implies Q and P. 0 1, if AND operation is applied, both should be true, then output will be true, else output will false. So 0 1 false means 0, 0 1 0, 1 0 also 0, 1 and 1 true. Now we check final output. P implies Q and P, then Q. These two tables. First is this and second one is this. So we check here first element where the 0. All three places it's 0. So the conclusion of this P implies Q and Q implies Q is 1 1 1. because this one is the first element, so it's false, then output is true. And second condition is both P implies Q and Q is true, means once, then the conclusion is 1. So this is when all the elements of last column is true or 1, then it is known as tautology. Here we can say that premises and conclusion should be true for validity, and if all the elements have true value, then it is known as tautology. So this is another way of saying that. Therefore, when we replace statement proposition with propositional variables, we have an argument form, means PQRST form. So an argument in propositional logic is sequence of propositions. All but the final proposition are called premises. The last proposition is the conclusion. The argument is valid if the truth of all premises implies the conclusion is true. An argument from form is a sequence of compound proposition. So valid argument in proposition logic, if the argument in the form of premises P1, P2, Pn and the conclusion Q, so we write it here, P1 and P2 and P3 and dash 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 Pn, then conclusion Q is a tautology. We can prove tautology or validity with the help of law of inference. So first law of inference is Modus Ponens, or we can say that law of detachment. Modus Ponens law said that if it has premises and conclusion, and premises P implies Q, and second premises is P, then the conclusion Q is true. Means if P implies Q is true, premises P is true, and this conclusion is true. If the statement in this form P implies Q, and P then Q is tautology, then this is the form of modus ponens. If the statement is written in this form P implies Q and P and conclusion Q should be true. So modus ponens is the translates of mod that affirms. rules of inference. First rule is modus ponens. We write it here in this form. P implies Q, P and Q. We take an example. Statement is written: if it is nice day, we will go to beach. Assume the hypothesis it is nice day is true, then the modus ponens, it follow that we will go to the beach. It's nice day, we will go to the beach. If P written here, it is a nice day, then we will go to the beach. We will go to the P. We will go to the beach. It is nice day, written here. If all these are true, then this is the form of modus ponens. We take an example. A valid argument can lead to an incorrect conclusion if one of its premises is wrong. All should be true. If any one premises is false, then it will be incorrect conclusion. So these are the rules of inference. First rule is modus ponens. P implies Q and P then Q is modus ponens. The second law of inference is modus tollens. In modus tollens, it is written in the form of P implies Q and negation Q and conclusion is negation P. If argument is in this form, then this is known as modus tollens. This is the second law of inference. And third law of inference is hypothetical syllogism. For this, argument is written in this form: P implies Q and Q implies R, then P implies R. So P implies Q and Q implies R, then P implies R. The arguments are written in this form. Then this is hypothetical syllogism. And fourth law, disjunctive syllogism. P R Q, negation P and conclusion Q. P R Q, negation P, then conclusion is Q. And all these are true, then this is known as disjunctive syllogism. And we write it in the form of P R Q and negation P, then Q. And fifth rule is addition. Premises is P and conclusion is P or Q, means P implies P or Q. And simplification, this is sixth rule. P and Q and conclusion P, then P and Q implies P. If this true and this true, then this is known as simplification. And conjunction, and for conjunction, P, premises P and conclusion Q, premises P and premises Q, then conclusion will be P and Q. So we can write it in the form of P and Q implies P and Q. And the final rule, means eighth rule of inference, is resolution. In this rule, premises will be P or Q and negation of P or, and the conclusion Q or. So argument if in this form, then this is known as resolution law. So these are the rules of inference. With the help of these rules of inference, we find out the validity of an argument. So we take an example. It is not sunny this afternoon and it is colder than yesterday. If we go swimming, it is sunny. If we do not go swimming, then we will take a canoe trip. If we take a canoe trip, then we will be home by sunset. We will be home by sunset. So these are the statements, and this is premises and this one is conclusion. So we convert it in the form of argument first. So let it is sunny this afternoon. We take it as P. It is sunny this afternoon. It is colder than yesterday. It is colder than yesterday. We let it be Q. We do not go swimming, so we take other variable R. We go swimming. We will take a canoe trip. We take it S. And we will be home by sunset. We take it T. So these 5 variables are there to convert in statement to proposition logic. So first statement, if it is not sunny, then we consider it here. It is sunny this afternoon as P. Then it is not sunny this afternoon. So it will be negation of P, and it is colder than yesterday. Q is it is colder than yesterday. We write it here, negation of P and Q. Second, if we go swimming, R, it is sunny, then it is sunny. If we go for swimming, then it is sunny too. So we write it here, R implies P. In the statement, if there is a written in if, then it will be conditional statement. If and only if, it will be biconditional statement. For that we use this symbol, biconditional. Here if, then it means conditional statement. So we write it here, R implies P. Third one, if we do not swimming, means if we do not swimming, negation of R, then we will take a canoe trip. Then we will take a canoe trip. So negation Q implies S. And next, if we take a canoe trip, S, then we will be home by sunset. T. And the final conclusion, we will be home by sunset tree. So all these converted in these propositional logic with the help of these proposition P, Q, R, S, T. Now apply rules of inference. These are the propositions, these are hypotheses, and in hypothesis these are the premises, and this is conclusion. So write it here again, and these are the rules of inference. With the help of that, we so that the rules of it is valid or not, apply the following rules of inference. So steps 1, P, negation P and Q is hypothesis. Simplify using rule 1. We get negation P, then R implies P is hypothesis, and apply rule Modus Tollens using 2 and 3. We get 2 and 3, we get negation R, apply rule Modus Tollens. Then next hypothesis, negation R and S, we apply the Modus Ponens using 4 and 5, and next hypothesis ST, we apply Modus Ponens in 6 and 7. We get final output T. So for this way we find out the conclusion is T. So this is using for this way we apply rules of inference and find out the validity of any argument without constructing truth table. We only apply these rules of inference and find out the argument is valid or not. So for this way we find out check the validity of any argument without using of truth table. Okay, thank you.